Hi everyone. Today we are going to solve LeetCode today problem, that is valid triangle number. So first of all, let's read the problem, right? So we are given an array nums, right? Return the number of triplets. We have to return number of triplet chosen from the array that can make triangles. If we take them as side length of triangle. So in order to solve this problem, you need to know the property of a triangle. Know a property of triangles. Let's say if this is a triangle, this is side A, this is side B, this is side C. So it is always there that A plus B greater than C, or A plus C greater than B, or A plus or B plus C greater than A. That is, sum of two sides, sum of any two sides of a triangle should be greater than the third side. This is a property you need to remember in order to solve this problem. That is, sum of any two sides of a triangle should be greater than the third side, right? So in order to keep this property in mind, we are going to solve this problem, right? Let's see the first example, that is 2, 2, 3 and 4, right? Now if we take 2, 3 and 4, that is 2 plus 3 greater than 4. Yes, it is a valid. Again 2, 3, 4, 2 plus 3 greater than 4. Yes, it is a valid. 2, 2, 3, 2 plus 2 greater than 3, it is a valid. You can take any other also. If it is making the correct, it's good, right? So this is like how we can check number of pairs. Let's say 4, 2, 3, 4, 4, 2, 3, 4. So number of sides we have is like 4, 2, 3. Is it there? Yes, 4 plus 2 greater than 3. First side. 4, 3, 4. Is it? Yes, it is. 4 plus 3 greater than 4. So 4, 3, 4 is done. 2, 3, 4. It is. Another one would be 4, 2, 4. Yes, it is. So these are the four number of we can say the ways we can make the triangle. Let's see how we can solve this problem. So what we can do, let's think about it. In case of 2, 2, 3, 4, I know that if I pick something here, all the number of element ahead of these two elements should be greater than those, right? For sure, right? For sure. So we can fix the any two element and then iterate. It is possible. Yes, it is possible. Another way, this is our one way. Just wait a second. Okay, so this is the first way that I had told you how you can solve the problem. You can fix any two number, run two for loops, for loop I till n minus 1, n minus 2, because we need at least two element ahead, for j till n minus 1, because I only need one extra element. Now I can run a while loop, right? I can run a while loop while that is k starting with j plus 1, and I can look up ahead all the number of elements. This is a brute force solution, order n cube. It will run, right? So let me show you the code. It will run. Like this one. This is how we can implement this one. So first of all, we are doing sorting. N is the size, count number of pairs, right? So n minus 2, we need two element, n minus 1, and then I'm running a while loop, right? So let's say I have a array 1 2 3 4 5 and 6. Let's say I fix these two element. I fix these two element. Now my third k, like up to what point, or starting with this, up to what index it is following this one should be k plus plus. That's what I'm doing, right? Let's say if while it is greater than, while the sum is greater than, let's say it reaches to this point, how many pair it is actually making? It's making this much pairs, like 1 2 3 1 2 4 1 2 5. So these are number of elements in between j and k. So it is k minus j minus 1, number of element in between, that is 3 4 and 5. That's what I had done, right? So now thing is how we can actually optimize our code. If you see, there is a very small thing that you can observe, that we are moving ahead to find a point, the max point, till our num of I plus num of j is greater than num of k. So this is like the sum, and I need an element that is just greater than this or equal to this. I need an element just greater than this, right? Is it fine? I need an element just greater than this. So what I can do, it is, we know that this array is sorted, and I need to find an element greater than the sum of these two elements starting from j till end. What I can do, I can simply perform a binary search. Let's say this is my array 1 2 3 4 5 6 7 and 8. Let's say this is my I, let's say this is my j. Now I need to perform binary search over this array and find an element just greater than or equal to also, right? Because if it is equal, then it is not following the property of a triangle. Let's say this is the element, we find it using binary search. After that we can simply do the same, that is k minus j minus 1. We have just removed that while loop with the binary search. That while loop we had changed this one over here, we had changed that while loop just to find an element that is greater than or equal to, right? So we can do something like a upper bound or lower bound, or you can write even your own function, right? So this is how you can solve this problem. And let's see the time complexity. For this code, it is around n multiply n, worst case n cube, plus this sorting function will take around n log n, right? So n cube plus n log n, which is nearly n cube. It will like as the maximum complexity of this problem, right? But see, if you use log n over here to find element, it would be n square log n, so time complexity overall would be n square log n in that case, and it would be very good. So that's how you can solve this problem. Okay, bye guys, and just give a comment and a like if you really like this solution, and hope I will meet you again in the next solution. Bye.